Welcome to another hands-on lab walkthrough. In today's video, we'll be going over a lab provided by cyber defenders called Web Investigation, where we are tasked to investigate an alert that was triggered due to an unusual spike in database queries and server resource usage. We have been provided with a packet capture, aka a PCAP, to analyze and identify any potential signs of suspicious activity. Let's get started. To begin, you want to head over to cyberdefenders.org and sign up for an account if you haven't done so already. Once you've signed in, head over to the labs section located at the top, and then we'll search for Web Investigation. And this is the one that we want. Now let's just quickly go through the scenario here. You are the cybersecurity analyst working in the Security Operations Center at Bookworld. Late one evening, an automated alert is triggered by an unusual spike in database queries. As the lead analyst in this case, you are required to analyze the network traffic to uncover the nature of the suspicious activity. Over on the left-hand side, we do have our tools of choice. There is Wireshark and Network Miner. Now, for this particular one, let's go ahead and use Wireshark. Click on Download Files, and do keep note of the password, which is cyberdefenders.org, all in lowercase. Once that is done downloading, let's go ahead and extract our file. Type in cyberdefenders.org, and then open up our PCAP. Now, right away, my Wireshark is going to look a little bit different than yours if this is your first time following along. Now, I did change up a couple settings here. I included a column called source port and destination port. I've also changed the time to UTC. And if you're unsure how to do this, I would recommend you check out my other lab walkthrough videos, as I do go through how to create them. To get started, let's go ahead and open up statistics. I'll do the capture file properties. The total elapsed time was 47 minutes, so this does contain quite a bit of packets here. Started back in 2024, March 15 at 11:39:21 a.m. And then it ended at 12:26:33. And it captured about 88,000 worth of packets, so that's quite a bit. Let's go back into statistics and we'll check out the protocol hierarchy. Let's see what we're working with. So we have some UDP data, hypertext transfer protocol, which pretty much makes up the majority of this PCAP here, aka the HTTP protocol. We have PNGs, we have multi-part media encapsulation, text data, HTML, and a GIF or a GIF, however you like to say it. Now let's go into statistics one more time, and we'll go into conversations and click into IPv4, sorted by bytes. So the most bytes are at the top, and we do see this communication between these two endpoints. These are the public IP address of 111.224.250.131 and 73.124.22.98. Because we do see two public IPs, my goal here is to understand which public IP is ours, or the legitimate IP of our client. So right away, what I'll do is take a look at the first packet. And looking at it, it is UDP. It's going towards 73.124.22.1, which is likely our gateway, and 73.124.22.255. And because I'm seeing this right away, it is likely that the network of 73.124 is our client's IP address, or client's public IP address. So I'll open up a notepad and then I'll type in 73.124.22.x equals, what was the client? Bookworld, I believe. Bookworld public IP. All right. And looking at packet number 5, we have a source, a public source IP coming in towards .98 on 443, and it's getting a reset ACK, meaning it's trying to connect, but nothing is listening in on 443, or there is just something blocking it. However, on 27, that is when we start seeing our 170 address hitting our .98 over on port 80. And this time, it connected successfully, because if we take a look under the info column, we do see the TCP three-way handshake, the SYN, SYNACK, and ACK. And I'll type in 170.40.150.126 over to 73.124.22.98 on port 80. Let's go ahead and follow this traffic. So I'll right click it, follow TCP stream. And because it is on port 80 and it is HTTP, we do see everything in clear text. Now we do see the host name of bookworldstore.com. So you know what, let me copy that and I'll put this into my notes. So 73.124, oops, 73.124.22. This one's .98, and this is our web server. Let's see here, the user agent that the source of 170 was using a Mozilla 5.0 Chrome Safari. Now you might be wondering, what is that? Well, let's copy that and we'll head over to a site called What is my user agent? Oh, sorry. What is my browser? That is the site that I want to look at. So whatismybrowser.com. And then from here, we want to click on parse your user agent. And let's paste that in here. So we can see that the public IP of 170.whatever was using a Chrome on Windows 10 to access our public web server, or to access our client public web server. Is it ours? Anyways, it doesn't matter, but to access the web server. You know what, I'm just gonna make sure. You are a cybersecurity analyst working in the SOC of Bookworld. Okay, yeah, to access our web server. All right, now let's go and take a look. Is there anything? Yeah, there's nothing here. Okay, because in our protocol hierarchy, we did see a bunch of HTTP stuff. What I'll do here is actually just filter for HTTP. Whenever I find myself taking a look at HTTP related traffic, the thing I like to do is filter for post request, because that is where I typically find interesting data. And to filter for that, I just need to simply add in .request.method equals post. And we do have 1, 2, 3, 4, 5 packets that have a post request. And these are going towards admin/login.php. So this particular IP address of 111.224.250.131 was trying to log in to our admin, or at least to the admin portal. Interesting. Let me put that into my notes. 111.224.250.131 admin portal packet. When did they start? 88664. Okay. And if we expand the HTML form, we can see that it's using the username of admin and password admin. Now your next question should be, did it succeed? And hopefully not. What about the other ones? We have admin and change me, default and default, admin and admin 123 with an exclamation mark. I feel like this one would be a little bit more likely that it worked, just because it has some digits and a special character. And then afterwards, yeah, we don't see another login, so I'm going to assume that it worked, but we can double check that. Out of curiosity, do we see anything here? Uh-oh, file to upload? Yikes. Okay, let's follow that. And yeah, we see it here. There's a post request towards this admin index using a user agent of this. So let's check out what this user agent is. Go ahead and paste that in here. And that is Firefox 115 on Linux. You know what, just in case, Firefox 115 on Linux is the user agent. And let's see, the file name that was being uploaded was this one right here, file uploaded. And here's the refer. I'm just taking random notes. I'm not sure if I need this later on, but it's always good to have. And this is the command that it executed. Paste that here. So it's doing a bin bash and it's listing a public IP address, which I believe is the same. 224.250.1. Yes, it is. Okay, on port 443. We can see that the file has been uploaded successfully. And I bet you that after this particular file was uploaded, we would start seeing some remote command executions. But for now, let's go back into HTTP and let's not get too ahead of ourselves. And let's take a look at what's happening here. We do see a public IP of 170, but that doesn't necessarily mean it's malicious or anything because, hey, our web server is out in the open. And based off of the request URI, and by the way, you likely will not see this column by default, it's just something that I added. For the 170 IP address, we can see that they're searching for Harry Potter, Dracula, War, Lord of the Rings, The Hobbit, etc. And then eventually we start seeing the 111 address, which is pretty much our attacker because we saw that they uploaded a PHP file and they ran that sketchy command. But anyways, this is the first time that it communicated towards our web server. And this is on packet 267. So let's write that down. First, communication, packet 267. And let me actually just cut that. Let's put that there. All right. We can see that it's doing some tests, doing a search. And now, what funky business SQL injection is going on here? We see search equal book and 1 equal 1. What is the user agent? Okay, it's the same user agent. I was wondering whether or not it might be something like SQL map, because that is an automated way of doing it. Wonder how long this person does that. And if we scroll down, we are starting to see some additional SQL injections. And hey, look at that. If we take a look at the user agent, it is SQL map version 1.8.3. When did this start? Yeah, this started around here. SQL map. Yeah, packet number 448. Okay, let's write that in. Packet 448, SQL map, version 1.8.3, SQL injection. Now over to the info column, we do see that it is failing. It's throwing a 500 error. So likely it's telling me nothing is being returned. However, for this one on packet 493, we get a 200. Ooh. And the input text, it says search for books. So it doesn't really reveal any sensitive information. Now, rather than just clicking on every 200 OK, what we can do here is just scroll all the way down until the SQL map is completed. And then from here, we can work our way backwards. Taking a look at the first 200 OK, scrolling down, we see welcome to Book World. Okay, that's fine for now. But what about this one? Where there was an SQL injection attempt and then there was a 200 OK. If we look at the data, it's returning something interesting. What is this particular string here? This tells me that this server is likely leaking some sensitive information. What if we check out the other 200 OK? Yeah, we're starting to see some interesting information inside of the title. What I'll do here is I'll copy out the request URI, copy value, and let's put this inside of our notes. So on packet 1663, potential sensitive information. And the SQL is this. Out of curiosity, I am going to copy out this SQL and then open up cyberchef.org, and let's paste that inside the inputs. Do a decode for the URL, and we can see a clean output here. Union all select null concat does a JSON array from bookworld's DB books. So it's grabbing information from this particular database. Now I'm curious, what other databases did they look for? If I go to the next 200 here, and let's copy out the request URI, and we'll paste it in here. And it's taking a look at the information schema columns. Let me copy that, paste that there, and I'll rinse and repeat. Go to the 200 OKs. This one looks pretty interesting. It has the street name and also the email. So this is likely the user database of some sort. Copy the request URI, paste that in here, and yeah, Bookworld DB customers. That is not a good look. I would hate to be these guys right now. Yeah, it's concatenating the address, email, first name, ID, last name, and phone number. Ooh. All right, so I went ahead and took a look at the 200 OKs, and there was one additional database here called Bookworld DB admin. And let's click into this packet number of 1589. So this one right here, actually, 1591, which is the response. We can see that it was able to spit out admin 123 exclamation mark and admin. So it is likely around this time at 12:09:32. Well, actually, no, because the SQL map was running automatically, gathering all that information. But it is likely that with this information, that is how the attacker logged in. And yeah, let's continue to take a look here. So we have our bash history, and looking at the user agent, we do see GoBuster version 3.6. When did this start? This started on right here. So they started at packet 1681. 1681, they used GoBuster. So we get a lot of 404 not founds. We have bash RCs. Again, what I like to do instead of just scrolling down and taking a look at each one of these, I like to scroll all the way down until the automation completes its thing. Because look at that, they're still going. And if I take a look at the user agent, I just want to make sure Yeah, it's still GoBuster. And we are nearing the end. So this is why this particular PCAP has this many packets. It's because of GoBuster and SQL map. And we are finally at the end. Wow, 88,562 packets. Here we can see a get admin from our attacker IP address. And then they accessed the admin login page. And this is where they started to enter in some of the credentials. Admin, admin change me, default. Now I'm wondering why they didn't just go straight to the admin123 exclamation mark, because SQL map did retrieve that information. But maybe it's just to generate some additional telemetry. But anyways, let's note this down here. At packet number 88699, the attacker logged in. Attacker logged in to the web server using admin123 exclamation mark. And then what did it do afterwards? We can see that they did successfully log in because it says, hey, welcome to the admin dashboard. Why, thank you. Yeah, what else did it do? We got our 170 searching Batman. Okay, we don't really care about that. The uploads. This is where they started uploading that PHP file. Yeah, right here. And then, yeah, just the PHP file here that we saw again. Now this occurred around 12/26/28. I'm curious to know what happened after that. I went ahead and removed my HTTP filter. That way I can see what happens. And is that it? Nothing else happened? There's no commands? Other than the one that we saw earlier where it was bin/bash towards the IP address. But other than that, there's nothing else. Oh man, what if I followed this? Is there anything? What? Well, shout out to Kevin Hughes. I was hoping we would find some pretty cool commands, but I guess not. Well, let's head back over to Cyber Defenders and let's start answering some questions. Alrighty, question number 1. By knowing the attacker's IP, we can analyze all logs and actions. Can you provide the attacker's IP address? That we can. It started with 111, and that's all I remember. So this one, 224.250.131. 224.250.131. Question number 2, can you determine the origin city of the attacker? For this one, I'll copy the IP address, open up a new tab, and I'll be using ipinfo.io. It is a great site with pretty accurate data. And we are looking for the city, I believe, right? Yeah, the origin city. And I am not going to pronounce that. So let's just go ahead and copy that out, paste that in here. Perfect. Question number 3, identifying the exploited script. Can you provide the vulnerable PHP script name? Yeah, that was in our notes. Yeah, right here. Wait, no, this is the PHP file, not the vulnerable PHP script name. So to find the vulnerable PHP script name, we need to take a look at the SQL injection because there was actual sensitive information being leaked. And if we take a look at the very left of the SQL injection, it is search.php. So this is the vulnerable PHP script name. Question number 4, establishing the timeline of an attack. What is the complete request URI of the first SQLI attempt by the attacker? The first attempt, okay. If we just search up HTTP, and I am curious, can we filter for our user agent? I'll just click on any random one. Oh, nice, we can. But it's not GoBuster. This one. So let's apply that as a filter. And the very first SQL injection, if I am not wrong, is this one. Oh, I cannot read. It says decode the value. Whoops, my bad. Okay, go to CyberChef, and there you go. This is the first one. Is it though? Is it though? I mean, it does appear to be it. Unless they mean that the server responded with a 200. Because there were some that responded with a 500. Yeah, okay, you know what? Let me change up my filter. I'll do an IP adder equals. Let's point it towards our IP of interest. And I am looking for HTTP. Go ahead and hit enter there. So when this person ran this particular query, it did get an okay, but I see some more stuff here. So their first SQL injection attempt was actually this one right here on packet 357. And we do see a successful, which is 200 OK. I am going to, right here, copy the value. And let's decode that. This one. And that is incorrect. Oh, looking at the format, it does want the dashes. Okay, I'm just going to manually type that in. Dash, dash, dash. Okay, perfect. Question number 5. Can you provide the complete request URI that was used to read the web server's available databases? So me being super smart, I went ahead and included the packet number, which is 1525. Let's go ahead and scroll down. 1525. Boom, right here. All right, let's copy that out. Go ahead and decode this. And how do they want the format? Yeah, okay, I'm just gonna paste that in and hope for the best. Sweet. Okay, nice. Question number 6. Assessing the impact of the breach. What's the table name containing the website's user data? That right there is called customers. But do they want bookworld_db or just customers? I'm looking at the format and they only want what I'm assuming is customers. Correct. Question number 7. Can you provide the name of the directory discovered by the attacker? Yeah, that is actually the admin. Okay, I should read the format. That is the admin. Question number 8. What are the credentials used by the attacker for logging in? That is admin. And admin123 exclamation mark. Finally, we have question number 9. What is the name of the malicious script that was uploaded? That was this funky little PHP file here. And hit submit. Perfect. Congratulations on completing this lab. Now that was a pretty fun lab, and I hope that you learned a lot by following along. If you want to learn more about how to investigate and experience what it's like working in a SOC environment, I would highly encourage you to take a look at my SOC community in the description down below. That is it for the video, and I hope that you found that informative. If you did, let me know by hitting that like button and subscribe if you want to. Remember to stay curious and do things differently.